0. So you're going like that, and then you come up with these numbers 1, 1, 2, 5, 5, 2, 1, 1. Where are these numbers coming from?
Possibility.
These are the numbers that we arrived at manually. Because if the number of nodes k is 0, then the number of ways they can vary is 1. If you have 0 nodes, the shape of that left subtree can only have one shape. But if you have 1 node on the left-hand side, k is equal to 1, well, you still only have one shape. The shape with 0 is an empty pointer here. The shape with 1 is a pointer to a single node. But if we have 2 nodes here, then those nodes can go, they can go left, left, they can go left, right. And that gives us 2 ways, which is also S sub 2. And finally, if I have 3 nodes, and they all are going to go to the left, then the ways those 3 nodes can vary is 5 different ways. And we got that by our analysis earlier, where we said S of 3 was equal to 5. So notice that once I get the number of ways that the left tree can vary, the number of ways that the right subtree can vary is simply what? It's a complement of that in a sense, because if you have 1, I have 5. If I have 0 nodes, I have 3, and 3 can vary in 5 ways. If you have 1, it's 1. Otherwise, you're going to have 2, and 2 can be in 2. Okay? If I have, this is how many nodes? 2, and this is going to be 1. And if I have 3, I can vary in 5 ways, but then this one can only vary in 1 way because it's going to have 0. So what am I going to do with those numbers? Now that I have those numbers, what am I going to do with them? Because I'm still trying to find out what is S sub 4. So n is equal to 4 in our example here. So this is going to be k, 3 minus k. K, 3 minus k. K is 0, 1, 2, 3. 3 minus 0, 3 minus 1, 3 minus 2, 3 minus 3. And these are the number of ways that those number of nodes can vary in each subtree. What are we going to do with these numbers? Somebody's got to come up with that. That's the easy part.
Add them?
Well, that would be easy. But it wouldn't give us anything. But we're actually going to multiply them. And the reason we're going to multiply them is because what happens, let's look at this example here. So this is the case where the left subtree has how many nodes? 1. And the number of ways that can vary is 1 way. But if I have 1 node here, I must have how many nodes here? 2. So that means there's only 1 shape possible here, but 2 possible shapes here. So if I take this fixed shape, one of them, and I match it with 1, and then I match it with another, so I can go down and down, I can down and over, 2 of them. So this shape, which is fixed, can be matched with 1 that goes like this, or 1 that goes like this, making a total of 2 different shapes. So the product gives you the different shapes of the left tree and the right tree, given that the split between the left and the right is as given here. At the bottom level, if 3 nodes are in the left subtree, that left subtree here could be in 5 different shapes. But that leaves the right subtree with 0 nodes, which only is 1 shape. So that 1 is being multiplied by 5 different shapes. So you can see what's going to happen is when you multiply them, 1 times 5, 1 times 2, 2 times 1, 5 times 1, adds up being equal to 14. Yes. So that's equal to 14. And so this is the product we're talking about. So we're going to simply multiply 1 times 5, 1 times 2, 2 times 1, 5 times 2. And the product we're going to get is S4 is equal to, well, S4 is not equal to, what's S4 equal to? 14, not 5. 5 is S what? S3. Okay, so let's take a look over here. And let's say we know that S0 is equal to 1, S1 is equal to 1, S2 is equal to 2, S3 is equal to 5, and now we know that S4 is equal to 14. And now I want to get S5. So to get S5, what am I going to do? I'm going to consider the tree having a root and having two subtrees. These subtrees, how many nodes are going to be between two subtrees? How many nodes are going to be, if you add up these nodes to these nodes, how many nodes are going to be between the subtrees? 4. So we can have 0 here, or 1, or 2, or 3, or 4. If we have 0, we're going to have 4, 1 is 3, 2 is 2, 1 and 0. And now, what we have to do is we have to basically decide what other values are going to be in here. So what we have to do is we now have to consider these corresponding lines in terms of the ways that those subtrees are going to vary. So what we have is we have S0, and then we have S4. We have S1, and then we have S3, we have S2, and we have S2, we have S3, and we have S1, and finally S4, and S0. And we are going to multiply this together. So when we multiply them together, we're going to get 1 times, what's S4? 1 times 14 is going to be 14. But notice down here, we're going to get what? 14. Also 14. It's going to be 14 times 1. What's S1 times S3? 5. So it's going to be 5. So 1 times S1 is 3, S1 is 3 here. Also going to be 5. And S2 times S2, 4. So we have 28, 32, and 5 and 5 is 42. So that is the 5th number. So let's see what's 42. So, going back to our notes. We can generalize that the nth number is going to be the summation from 0 to n minus 1 of Si times Sn minus 1 minus I. That's exactly what we did with those trees. That's the formula. So for S4, we're going to summate from 0 to 3, just like for n we go 0 to n minus 1. So for 4 we go 0 to 3, Si times S of, this is going to be 4 minus 1, so it's going to be 3 minus I. And you can see how we have these guys in here. So that's our formula. So the formula, in general, is going to be the summation. So if we have S of n is equal to the summation as I goes from 0 to n minus 1. And we're going to have S sub I times S sub n minus 1 minus I. So that's our formula. If you look at it graphically, actually, notice that S0 times S4 is this product, right? S3 times S1 is this product. But notice that this product occurs twice, and 1 and 3 occurs twice. And this one in the middle actually occurs once. This is the shape of this when n is equal to what? When n is equal to 5. When n is equal to 5, we have 5 of these. But what happens when n is equal to 6? When n is equal to 6, we're going to have S0, S1, S2, S3, S4, and S5. Okay, and then here we're going to have S5, S4, S3, S2, S1, S0. So this product is going to happen twice. 1 and 4 is going to happen twice. And 2 and 3 will happen twice. Why is that different? Well, it's different because what we have is we have an odd number or an even number. And when we have an even number, everything's doubled up. So that's the basic idea. So you can see how the relationship works. These numbers actually have a special name, and they're applied in a couple of few instances. One of them is the tree shape, which I like. And so interestingly enough, this summation, which doesn't look obvious, has a closed form. Has a closed form, and the set of numbers that we're talking about are called the Catalan numbers. Catalan numbers up here. And the formula, the closed form formula for them is actually 1 over n plus 1 times the binomial coefficient of 2n over n. Do we go over these binomial coefficients? Yes, let's just go through this. Everybody's okay or not? So we'll try to see how we can actually. So if you think about it, this would be a very difficult thing to do if you wanted to look for example, the 50th Catalan number. It would be a lot of work. It would be a lot of work to compute it, but there's actually a direct way. And it's not a trivial solution, so it's not one I expect you to solve, but I expect you to know that this is the formula, and we can look at it. So in general, when we're talking about binomial coefficients, they typically look in the form of an integer like a over b. There's no division sign. So this is a binomial coefficient. And it's used a lot in computing probabilities. And it's got a very simple definition. So basically, this binomial coefficient of a over b is going to equal to a factorial divided by b factorial times a minus b factorial. That's a definition of the binomial coefficient. Let's look at an example. So if I had the binomial coefficient, for example, 5 into 2, I would write that as 5 factorial on top. On the bottom, I would have 2 factorial, but then I would have another factorial, which is the difference of the top and the bottom, which is going to be 5 minus 3, 5 minus 2 factorial. So this would simplify to 5 factorial divided by 2 factorial times 3 factorial. Now to simplify it, you should recognize the fact that 5 factorial represents the product of the numbers 5 through 5, 4, 3, 2, 1 product. But 3 factorial represents the product of 3, 2, 1. So what's going to happen with the 3, 2, 1s? They're going to cancel. So therefore, what we have here is only 5 times 4. And then that simplifies everything here, right? Because the 3, 2, 1 in the 5 factorial cancels with the 3 factorial. So now we only have 2 factorial left, but 2 factorial is just 2 times 1, and that's only what? 2. 2. So now you can look at this one here, and we have 5 plus 5 times. So that's a 4. So what we're going to do here, since it's times, we're going to say this is going to be 1, this is going to be 2. And so this is going to be equal to 10. This is equal to 10. So that's how you compute the binomial coefficient. There's an interesting interpretation of, and sometimes the binomial coefficient is called the combinatorial coefficient. It's another name for it, combinatorial coefficient. And sometimes we read it by saying, instead of saying binomial of 5 into 2, we can say 5 choose 2. 5 choose 2. So it has another very interesting interpretation. And that is to say, if we have 5 objects, or 5 students, for example, look at the front row of this class. 1, 2, 3, 4, 5. We have exactly 5 students. Okay? So the question is, I'm going to send 2 students from this front row on an assignment right now. They're going to go somewhere. The question is, how many ways can I choose that group of 2 people? And the answer is binomial 5 into 2, or 5 choose 2, 10 ways. There are 10 ways to combine them. We can count them. So I will point to the people. 1, 2, 3, 4. You've been paired up with everybody. 5, 6, 7, 8, 9, 10. See what I did? That's the only way I can pair them up. So now the question is, if I am choosing the 5 people from the front row at random, what's the probability that I choose these 2? 1 out of 10, right? Does that make sense? What's the probability that I choose these 2? What's the probability that I choose her as a group of 2? No. I mean, I'm going to choose a group of 2. What's the probability that she's in that group of 2? No. That's a good guess. That's a fast answer, but it's not very accurate. So I'm going to choose a group of 2 students from the front row. What's the probability at random? What's the probability that she is in that group?
5.
Keep going. You're close. The first answer was close. Your answer was close.
4.
Okay. Because think about it. How can she be in 5 different groups? She's going to be either a group with him, or with her, her. It's 4 different groups. She can't be in a group by herself. Sorry. I know you like yourself, but you cannot be in a group by yourself. Okay, so there's only 4. Okay, you see what I'm saying? So that answer is correct. So there's 4 ways. The probability is there are 4 groups since there are total. So the probability is 40% that she will be in a random group. Does that make sense? Okay, so it can be very, very useful, and we'll come back to binomials, binomial coefficients, because they're very, very useful. So we know that S of 4 is what? 14. And do you remember S of 5? 42, but we don't know S of 6. We don't know what it is. So we're going to try to find this closed form. But before we find the closed form, it would be nice to get a good idea that this is actually going to work. So let's try something we know. So let's try S of 5. So C of n, which is going to be the same as our S of n, or S of 5 in this case, right, will equal to 1 over 6 times the binomial of 10 over, okay. So we're going to have 1/6 times 10 factorial divided by 5 factorial times 5 factorial again, right? because it's going to be 5 factorial from the bottom, and 10 minus 5 is 5 factorial again. So let's simplify it. So what we have is we have 10 times 9 times 8 times 7 times 6. That leaves me, that simplifies this over this. Over, I still have a 6. I'm going to put that 6 over here. And 6 is coming from here, guys, right? And then I have 5 times 4 times 3 times 2 times 1. This can be simplified, right? This 1 doesn't really matter. 1 is just 1, right? So let's see what we can do. What's 10 into 5? 2. What's 9 into 3? 3. What's 8 into 4? 2. 8 into 4 is 2, right? Okay, 8 into 4 is 2. And that's all I have right now. So let's see what we got. So we got 3 times 2 is 6. 6 times 7 is? 3. What's happening to 2? Oh, 2 is 2. So what do we got left? What do we get the 42? I lost it. Oh, there's 2. Okay, so 2 times 3 is 6, 6 times 7, so this is equal to 42, which is correct. You see how much better this is, right? Because you can look directly in here. So S of 6, S of 6, following the, this one's going to be 1 over 7 times binomial of 12 over 6. So we're going to have 1, 7. Then we're going to have 12 times 11 times 10 times 9 times 8 times 7. That takes care of the 12 factorial over 6 factorial. But I still have a 6 factorial, which is going to be 6 times 5 times 4 times 3 times 2. I can skip the 1. And then I'm going to put the 7 in here. Okay? Put it in here. That's what I have here. Well, let's simplify. This is going to be 1. I like simplifying it in 1. It's always good. Otherwise, we get screwed up. Okay. So 12 into 6 is 2. 10 into 5 is 2. 9 into 3 is 3. 8 into 2, this is 2 times 4 is what? 8. What's 8 into 8? That's going to be 1. That's gone as a 1. So it looks like we got everything gone from the bottom. So what do we have left? We have 2 times 2 is 4. 3 times 4 is 12. 11 times 12. I don't know how much that is, but 10 times 12 is 120. 132. Now, are we off or are we at that correct? I think it's correct. But anyway, if it's not correct, then we screwed up rather than as a formula. Okay. So this is a closed form, so it's a very, very interesting result. So what I did want to look at with you guys go back to the previous one. Okay, so I think when we finished discussion of this, we decided that the solution to the average complexity of quicksort was a very, very interesting solution, very powerful solution. Oh, so you can't see it. So this was the result that we did, I think, was it last time? I think it was last time. So we had 1.38 N LGN. You guys know how I got this? How do you go from here to here? mathematically. Because I get ln and I have lg all of a sudden. How do you do that? What's ln in terms of log base 2? We have to use what technique? We call it change base rule, right? So ln n, what's ln n equal to? If you're going to change the base for the log of n to be lg of n. So ln n, natural log of n, is equal to lgn divided by, so it's ln n is equal to lgn divided by lge. And lge is just a constant. 2 to what power is e? I don't know, 1 point something or other. So when you divide that, it brings that 2 down. Because here we have basically 2n plus 2 times ln n. When all of this is simplified using a change log, you end up with this, and this is a very famous result. And the reason we changed to lg is because the tree is binary. So lg has a real meaning. It has the meaning of height of the tree. Okay, in general, the best height, I should say, the best height. So therefore, since the best height is ln, in this case, it's going to be 1.38 n. So that's the average complexity of quicksort. Okay? Now, we also looked at and considered this tree earlier today. We should save it for next time. We'll finish up. Okay, let me save it for next time because we're running out of time. So just as a quick notice to everybody, we will not have, so Thursday we'll meet. Wednesday we'll meet. Okay, there. Thank you. Wednesday we're going to meet, which is great. Next Monday there are no classes at UB at all. So there's a little bit of a mid-semester break. You get a whole 2 days off. Monday and Tuesday, but if you look at the calendar, they'll tell you they'll give you Saturday and Sunday off too. So it's really 2 for the price of 1. So anyway, so we'll have a class on Wednesday. I will give you some ideas about what's coming up on the midterm. No class on Monday, no classes on Monday, including our class. And then on Wednesday we'll have the midterm. Okay? For the midterm, you can bring 1 sheet of any formulas you want, anything we did, like the summation of I to the I. Have that handy. Because I will definitely ask you to solve some problems. I'm going to try to make the problem so that it's not earth-shatteringly difficult. It should be reasonably easy to do. They should be no harder or easier than the homework problems, and I will look at the homework problems very, very carefully when I create new problems for this exam. So you'll probably get 3 or 4 problems, but they're not going to be, if they're going to be harder, they're going to be closer to the homework. If they're going to be easier, then I can move them away from the homework, if you know what I'm saying. So if you did the homework, if you spent time on the homework problem, and I give you a hard problem, it's probably going to be similar to the homework problem, so you'll be able to adjust it accordingly. So 3 or 4 problems to solve, and probably, I would say maybe 15 to 20 multiple choice or objective questions. Could be true or false, could be multiple choice, something like that. And for my multiple choice question, for my true-false questions it's true if it's always true. Remember, we did proofs, so we know about that kind of stuff. So if something is always true, then it's true. If something, I say this is blah, blah, blah. But the fact is, it might be, or it might not be, depends, you didn't give me enough information, then that's false. So your answer should be false if it's not always true. Does that make sense? Something that's true is something that must always hold true, regardless of anything else. Okay, so what I'll do is I'll try to work a little bit on the midterm exam that I'm going to prepare for you guys. And what I'll probably give you is I'll give you a study guide. I'll send it out by Canvas. So I would say by Thursday or Friday you will have a study guide. Things that I'm going to, because what I'll do is first I'll do the test, then I'll do the study guide. So I can focus you so that you're not all over the place. Okay, so know certain things. I mean, you should know everything, of course, but you want to be able to answer questions successfully on the test. So that's all I have. All right? All right, any questions? And you guys got the last assignment out, right? Number 4 that you're working on? And that, I believe, is going to be due on, what's the due date on that? No, I'm going to understand that. You need more time? You don't need more time? Everybody got it done?
Yeah.
You guys are that amazing? Really? Well, I should give you a 5th homework assignment then, so carry you through. I may do that, okay. I may give you like a short one. Okay, so everybody did good, right? It's very, very impressive. All right, see you on Wednesday.